Hi everyone, my name's Alan Budden. Today I'm going to talk to you about EnerPHit standards and how that could help you. So to start with, introducing myself, my name's Alan Budden. I'm an architect and a sustainability consultant. Been very involved with sustainability most of my life, and now run a small practice called Eco Design Consultants, specialising a lot in Passivhaus. So today, partly I'm here representing Eco Design Consultants and partly the Passivhaus Trust as one of their technical advisors. On the screen, you can see a couple of our completed projects from completed passive houses. So this one here was the most airtight building in the country for many years. More recently, it's just been pipped by somebody else. And we have various EnerPHits, so passive house retrofits, including this one down here, which actually got to full passive house. And we're also taking passive house that step further, so looking at passive house plus and premium, which is basically adding renewables to the house to make it completely zero carbon in terms of energy. In fact, energy positive. This house here, the full roof of PV, electric car, basically an income from the house, and no cost of charging the car at all. So perfect, really. That's what we should all be doing for most of our houses. Okay, so just looking quickly at the agenda. So today I really wanted to define quite quickly what passive house and EnerPHit was, go through some key principles, and then look at a step-by-step approach, which is quite an interesting way of doing it. I think it's what I'd try and encourage you guys to look at, particularly because there's the reduced amount of energy target. So quickly looking at the technical side of EnerPHit, you start off with a number of technical things, so very much around sort of air tightness. So air tightness down to 0.1, oh sorry, not 0.1, 1 air changes per hour for the EnerPHit, the passive house retrofit standard, or 0.6 for the full passive house. What's interesting, I think, with the whole of the EnerPHit and the passive house targets, it's not necessarily just about getting your energy down, reducing carbon. It's also about comfort. So you can see that getting an airtight house is not just about reducing your fuel bills, but it's also about making it more comfortable, less drafts as well. So it's doing a number of things. Other technical criteria, which often is missed, to be honest, when people talk about passive house and EnerPHits and stuff, is things like the internal surface temperatures. It's part of the requirement to make sure that every surface is at least 17 degrees all the time. That means there's no air movement between the cold surfaces to the warm surfaces. So it is about comfort. It's not about energy. And also that also means that the surface temperature means not just about comfort, it also means that there's no risk of condensation and then associated mold and other things. So it is comfort. So again, overheating at less than 10%, the same as passive house for the EnerPHit. Ventilation, again, the same as passive house. The heating demand, this is some of the things that are different, obviously, for an EnerPHit refurbishment project, because obviously it's slightly more difficult because you can't change the orientation, you can't change the windows. So it is relaxed to 25 kilowatts per meter squared, except for a few other locations. So if you're in London or the Southwest, that could be 20 kilowatts the target. Or if you're parts of Scotland and Northern England, then it could be up to 30 kilowatts. So do be careful. It's not always the 25 kilowatts. Also, we have to look at the primary energy. That's the energy in terms of generating power from the power stations and so forth, not necessarily just the stuff delivered. It's not the meter reading. It is from the power source. So it does depend a little bit on what power and what energies you're using, whether it's electricity, gas, or so forth. So very similar requirements to the EnerPHit one, but there is more leeway allowed. So there is some flexibility, and it does change a little bit depending on which type of system you're going to in terms of certification. Or you can look at the primary energy renewable, which is a newer version, which then looks at adding renewables, and you can give you a bit more flexibility. So yeah, as I was saying, really, I think it is the passive house criteria isn't just about energy, it is about health and comfort, which I think is really important. So you can see that all the passive house criteria, which you spoke about just now, the effects are kind of reducing mold, making air cleaner, removing pollutants and so forth. And the results basically become a nice, warm, comfortable building, a healthy indoor air quality, and being comfortable all year round. So it's summer and winter. Obviously, if you don't do these things, you kind of have cold houses, people in fuel poverty, immune systems not working properly, increasing of illnesses and respiratory items, It's got a discomfort generally from maybe hot and cold. So it is about those things. And I think, to be honest, a lot of these retrofitting houses, the comfort and the health as a society is much more important than just reducing the fuel costs. Obviously, climate change is an important part of it, but yeah, the health and comfort is really worth looking at. So I think, to me, we'll talk about it a bit later. In terms of the strategy, because I know with the bid, it's 90 kilowatts per square meter rather than 25. So you haven't got the money to spend to get down to 25, possibly, unless you're putting in money from elsewhere. So to me, it's about doing a number of things well, and then maybe going back in stages and do things as you can. That way you can make sure that these sort of things are addressed, and you're not going to sort of still have fuel poverty and other things. But we'll talk more about that later. The other thing I really like about the Passivhaus and the EnerPHit and that system is it works. There's been a number of studies done by a number of universities checking out to see, okay, this is what the designers predicted the energy usage would be, or what was it in reality? So that each of these graphs, these columns on here, the blue one is what was designed at, the predicted, and the red is the measured. So you can see some of these double. So you're actually using twice as much energy as it was designed to, which isn't great. And generally, they're all more than it was predicted to be. So I kind of think this is going to be next Dieselgate coming along, where EPCs are going to be questioned and someone's going to be looked at for that. Interestingly, though, the ones down here, these are the Passivhaus ones. Not only are they the lowest in terms of the energy usage, but the differences are really small. And this is this was a Leeds Metropolitan University study, but there's been some more recent stuff done by Oxford Brookes, quite a large study of all sorts of things, and that was one of the things that they found from all the data, that the Passivhaus ones were much more reliable in terms of the predicted and the actual than any of the others, and which is really good, considering again it's such a low amount anyway. So there's more room for error when you're doing such a small amount. So just quickly looking at some of the main principles with Passivhaus and the Passivhaus retrofit standard. This, to be honest, is useful stuff for whatever you're doing in terms of building, just basic building physics, really, to try and make your building as efficient and as comfortable as possible. So on the right, I've got a graph there which shows you roughly what building regulations new build would be for a house. So you're roughly talking about 85 kilowatts per square meter energy usage. It does vary because of shape, because building regulations doesn't take the shape into account. So the first things we would do with Passivhaus is super insulation. I think that's what most people think. It's all about big duvet. So U values are less than 0.15. UK is probably nearer to 0.11, 12s, that sort of range, to be honest, to get them to work in the UK, unless you've got really big buildings. Efficient shape, that can make a huge difference. And to be honest, I think is really important. It's one of the biggest takeaways, I think, if you can take it away today, is make your house as efficient shape as possible. Don't have little recesses and other things. And we'll talk a little bit more in a minute on that. Triple glazing. This is really important, and it's, like I said earlier, it's about the health and comfort as much as the energy reduction. Having triple glaze means that the surface temperature of the glass is at least 17 degrees, so there's no cold surfaces, no air movement, no risk of condensation. Air tightness of 0.6, again, you can see a huge jump there. So that again is really important. And again, it's the comfort and health as well as the energy reduction. So again, really important and potentially not that expensive to do. Complicated, can be, needs a lot of good workmanship and stuff, yes, but if you use the right materials and the right types and so forth, you can get fantastic results that are long lasting, but it does, attention to detail is needed. Once you've done that, you've got a nice airtight building without any drafts, you do need to look at your ventilation system. So you do need to put in an efficient ventilation, bringing in nice fresh air, pre-warming it with a stale air going out, so transferring some of the heat across. These machines are about 90% efficient, so it does mean if you're extracting heat from the kitchens and bathrooms at, say, 20 degrees, it's probably coming into the living rooms and other spaces kind of 19.5, depending on the temperature outside, obviously, how efficient that is. But it is obviously losing heat, not gaining it. Then looking at thermal bridges, so making sure that the insulation is continuous, there's no gaps, there's no large lumps of concrete for window sills and concrete gutters and things like that, which you may have on some of your properties, that can cause issues. So do look at those issues and reduce those down. Again, it's about the surface temperatures as much as the energy reduction. And you do all that, you get high levels of comfort, good health, minimal heating requirements, happy tenants, tenants who are going to pay their bills because they can afford to now, tenants who aren't going to worry about the heating going off because it will last. The heat will stay in the house for longer, so they won't be chasing you up to get their heat pump mended just because it stopped working 10 minutes ago. It will take a few hours or days even to cool down, depending on the time of year. So all that, you get to the Passivhaus Standard. So the Passivhaus EnerPHit Standard is very similar in doing that. So what we often look at, particularly on the retrofits, is looking at kind of a whole house plan. This is some work we did for a housing association down in London, looking at a large block of flats. So this is the type of report we do, and I'm going to take a few examples from that as we go through. We also looked at the airtightness strategy for them in terms of how that might be helpful. This is the other really important effect here, the efficient shape. So looking at this is some work we did for the NHBC Foundation, looking at the importance of shape and how that really affects it. So here we can see a mid-floor flat and a bungalow. So what we're looking at is the heat loss area. So on the flat, you can see here the pink areas where it's losing heat. So the front wall, the back wall, and the side wall. So that totals 74 meters squared of heat loss. If we had the same unit as a bungalow, that's 279 meters squared of heat loss area. So that's now adding in the floor, the roof, and the side wall. What we did then was we used SAP to then calculate, using building regulations, what the heat loss would be of each of those units. So the mid-floor apartment, 2,000 kilowatts per square meter of energy usage. The bungalow, 4,500, so over double. So you can see how much extra energy that takes just because of the shape of the building and the heat loss area. On the graph here again shows some of the other units. So going from mid-floor apartment, which is the most efficient, to mid-terrace, to semi-detached, to detached, to the bungalow being the most inefficient. And so along the bottom, what we call the form factor, that ratio between floor area and surface area losing heat. So really, really important. So for passive houses, we target that to less than 3. The example I showed earlier of the big block of flats, that was actually down to 1.5. So way, way easier in terms of trying to achieve that, and less insulation and other things needed. All this is in that document I said earlier, to the NHBC Foundation document, The Challenge of Shape and Form. This is a free to download document from the website. So if you go onto the NHBC Foundation website, you can search for that and download it. I would highly recommend reading it. One of the big findings we find is shape. So often when we're doing a retrofit, we find that the front door of the house is recessed to give a little bit of shelter for when someone comes in. But if we can move that door out to the front of the wall, then that can make a huge difference. So on a full passive house, that can make a staggering 12% difference in the heat loss. It's also easier to do the work because if you're replacing the door anyway, infilling it here is relatively easy, whereas if you start leaving it back, you've got to insulate a bit of the walls on the sides, and it all starts getting a little bit complicated, and the losses going up into the room above. It's often why those sort of bathrooms and stuff that are above this are often very cold. Then second factor really in the passive house principles really is insulation. So this is the big woolly jumper, the big duvet, or however you want to call it, really over your house. Down here, there's some top tips. We won't go into that because we haven't got much time, but really just make sure insulation is continuous, no gaps, and do look at the insulation, the performance, the lambda value, and the thermal conductivity, because all insulation isn't the same. Sometimes we find our builders trying to use different insulation which they think is the same stuff, but it's not. So do look at the thermal conductivity. I mean, the other thing with insulation is often with the refurbishments, we're often looking particularly for nice brick on the outside or stone or other things. We're looking at doing stuff on the inside. So often people are tempted to think, okay, insulated glass, well, that's nice and easy. We can slap that on the inside and it's all good. The issues with that really are you need to, following the manufacturer's instructions, put in a ventilated void behind, so you've got battens and other bits and pieces going on. They're saying a ventilated void, so you really need to be ventilating that void. It's not just a case of having a void. So really you should be drilling holes through to the outside. And if you start doing that, what you're doing is you're bringing in cold air behind that. So that's again potentially bringing moisture with it, causing other issues, and you're losing all the thermal performance of that external wall. So not really a great idea. And it also gaps and air paths are good routes for heat to escape. So really careful in terms of condensation and moisture and stuff with these sort of routes. What we would recommend is not having any gaps. So if you don't have gaps and you've got a solid wall, you do need to make sure your materials you use are vapor open, so you can have moisture that can move backwards and forwards through the room. So things like the thermoroom wood fiber is a great solution. Or another really nice solution now is the diathanite, which is a cork line plaster that you can spray on. And again, if it's really uneven walls, you can use that stuff really well. And you can keep uneven walls. You can keep it having that character of an old cottage or whatever you want. Or other options, which may be slightly cheaper, would be things like using mineral wool between timber studs. But again, look at the thermal performance. Go for the 32s in terms of rather than the 36s or the 44s. So do make sure that you put some good stuff in. Again, do check the condensation risks. Do make sure that it's all breathable. It's all really important stuff to make sure this works. Be really careful. So what we do, and this is the example for that big block of flats, we measure it out. So we look to see what the different installations do. So we're looking here between the diathanite to the mineral wool and the different coloured lines here. So you can see as you increase the thickness of insulation, how that improves the performance. In fact, what you find is that after a while, it gets worse and it starts tipping up. That's because you're losing floor space, and in the passive house calculation, that's taken into account. So the form factor is getting worse, so it starts to deteriorate. In reality, it's not quite as steeply going up, because this is just looking at one element. So it's losing heat through all of the floors and the roof and other things on this single example. So it is a bit slower in terms of going up if you start looking at that once you've got the rest of the measures in place. And some examples of things there. So kind of 20% improvements just with 100 millimeters of diathanite or 80 mil thermoroom, that sort of thing. External insulation is obviously much better if you can. So if you can put it on the outside, brilliant, because you can put more and there's much less risk of condensation. And again, if you've got tenants in place, you can put lots of stuff on the outside and away you go. So on here, kind of getting up to 25-26% improvements with 150 mil of a mineral wool. So something like this, some rock wool, external wall insulation. So fireproof as well, which is obviously really important to make sure that is the case these days. And you can see really good stuff. Roofs, again, similar things. So we graph those all out. So making sure that there's no condensation. Do make sure if you're doing refurbishing roofs, you put insulation on the outside, not start stuffing it between joists, because you can get moisture build up here that can cause damp, unless you use some really clever single directional air tightness membranes. There's one on the market from Sega, which we occasionally use too. But do make sure it's really correct, and maybe get them to sign off in terms of moisture. Insulated floors, again, all sorts of options there. We've looked at all sorts of stuff in the practice, from just putting large lumps of insulation on the ground with concrete and stuff on top, to filling in between floor joists, to spray foam, to glass aggregates, all sorts of options. On the block of flats we looked at, this is sort of things we could do. And to be honest, if there's a screed, you could take the screed up and maybe put 60 millimeters of kingspan on that, and you've only got 3.5% improvement. Or maybe some aerogels to 20 mil if you're really short of space. They're not that different from kind of digging it all up and going to 150 mil Certex underneath. Okay, a few more percentages, but there is options there. And again, you might look at doing stuff around the perimeter. So just talking about that, thermal bridges is the next item. So that's really making sure there's no gaps. To me, it's a bit like the old sleeping bags with a metal zip. So nice and snug and warm, roll over in the night. That metal zip is a killer. You can really feel that heat being lost. So as I was saying earlier, with floor insulation, other options is to start look at perimeter insulation. So a typical thermal bridge DOS here, this was the flats again. So you've got a big concrete floor. There's a real heat loss going out through the edges. So you do need to look at what happens at those points. This is obviously potentially colder, so potential moisture issues and condensation and mold and so forth as well. So sort of thing you can do, perimeter insulation, so insulate around the outside, increase the distance that the heat needs to travel, so more thermal resistance as it goes through the brickwork, reduces the thermal loss, increases the temperature internal. So really worth doing. So on that one, we looked at some perimeter insulation, and I think, how long was that? That was 2.4 meters, so some quite big external insulation. But we're getting up to similar numbers of improvements with that sort of 2.2% compared to the, was it 3.5 inside. So not as good, but it's still starting to get there. So there is options if you need to. Again, much easier if you've got tenants in place. Again, look at the thermal bridges. So other areas on that property where the concrete intermediate floors going through, so you are getting losses again there. So you do need to think about it. So ideally, you're trying to insulate that on the floors and the ceilings below, if you can. Number 4, another really good principle is the draughts, so reducing the amount of heat loss through the windows and not through the windows, through the fabric. Building regulations has a backstop of 10, perpendicular of 10. If you put that all together in a 3-bedroom house, it's the size of a window that big. So it's really, really big. Obviously, it's not one, so you really need to do something about it. In passive house terms, if you did a full passive house and you've got your heat demand down to 16 in this case, if you increased it to an air pressure rate of 10, so much more drafty, that goes from 16 to 45 or from 14 to 66. So you can see huge differences in how really, really important it is to keep those drafts out in terms of your heating load and your comfort and stopping insects and dust and all sorts of stuff. It's very much, I think, in terms of the air tightness, what you want to look at is it's about a Gore-Tex coat. It's something that's breathable, that lets water vapor through, not the cagoule, which is like the polythene bag. But do make sure that the buildings are breathable and moisture open in terms of vapor, if that's the type of construction you've got. Good ventilation, I think I spoke about this earlier. So yeah, so taking the warm stale air through the heat exchanger, bringing in the fresh the fresh air from the outside, warming it from the stale air, and then putting it into the habitable rooms. Again, those are the things you're achieving here. Kind of extra, so with the air tightness on that building is really big, a 13% improvement. Often it's much bigger than that, the percentage improvement, as we saw earlier. And then putting in your ventilation system, so you're getting another 10% improvement on top, and obviously much healthier, better, happier tenants. Excuse me. Windows, they're really important as well. So I said earlier about the temperature differences. So basically, if you use double glazing, likely so you can get internal surface temperature 16, triple glazing 18. Therefore, the temperature differences from internal to outside are -1, 5 degrees with the double, 3 degrees with the triple. So very much it's around about the health and surface temperatures to make sure that we always recommend going for triple if you can. Not necessarily that much more expensive. Typically about 10% more at the moment on some good windows. Obviously, cheap windows, percentage becomes higher. But when you're doing the triple glazing, don't forget that we still want to fill it with argon. We still want the low-E coatings. And the other thing that people don't often look at with windows and stuff is the G value. So it's not just about the heat losses, it's about heat gains. So the G value is the solar gain. So do check that out as well, and that can make a big difference. The other really good tip I'd put in terms of windows is this is a slide that I use for when I teach at Birmingham City University to the architecture students. So 3 different windows, all the same size. Window B, basically 13% more losses, purely because of extra frame. So the frame is usually worse performing than the glass, and also it's not gaining a solar gain. And then if you go to option C, 32% losses. Interestingly, window C is probably 30–40% more expensive than A as well. So it's a really win-win by trying to reduce the amount of frames, keeping nice big openings. I think everyone's happy with that, as long as, depending on the look, obviously there is sometimes with the older properties that you want to keep the heritage look and so forth, so that can obviously limit it. Yeah, so good orientation, but shape I think is more important than orientation. Yeah, and all that again is in another document we helped produce for the NHBC Foundation and called Windows Making It Clear. Keeping cool in summer, again, really important. So to me, that's about your top hat or your hat and making sure that the shading is right to try and reduce some of those solar gains, or really in the first place making sure you don't have too big of windows. Well, on a refurbishment project, that's not usually a problem because usually windows have been nicely sized and not too big. It's the newer buildings that we're finding that people are trying to increase the glazing more than really is really needed. And if you are going to have shading, make sure you use it properly. Accurate methodology, yeah, that's another really important thing we find. It's about making sure the software that you use to measure things is accurate and you put in all the data you need. That's why we use the Passivhaus planning package rather than SAP, which SAP can be okay, but you do need to make sure if you do, you put in all the data. So if you are putting in windows, putting in the frame factors, the percentage of glass to frame, that all that can go in and is often not necessarily carried out completely. So this is the type of glass we do. So you can see kind of this house here, a retrofit of a semi-detached. So 9% on the external wall insulation, an incredible 53% improvement in terms of air tightness and MVHR, and total with the Passivhaus retrofit, an 88% improvement on the total building. So a really good result there, and a very happy customer. So yeah, top tip: appoint someone who knows what they're doing. So appoint a Passivhaus designer with experience. Make sure that you do know what you're doing. And certification, yeah, I'd always recommend going for certification because it's a whole QA process that can ensure that the building does do what it says it's going to do. And there's another set of eyes, another set of checking to make sure, again, that it all works. Phasing of projects, this is something, again, I think is really important, particularly on this sort of process at the moment where you're looking at retrofitting large amounts and you've got fairly limited budgets in terms of what you can do. There's very tempting to do lots of places and do a shallow retrofit and basically do lots in lots of different places and make a good improvement, possibly more than if you did spread out. So in a deep retrofit, you might just really concentrate on maybe the external wall insulation, might be your windows, it might be the roof, could be all sorts of things whatever's really important and big wins and so forth. So you might not do as much in the first step. But it does mean that you can keep going. It does mean that if things like the floors aren't done, you can go back later and do those floors. It's not about doing a little bit everywhere. To me, that really does mean that we're going to get to where we need to get to in the end. And also in terms of comfort and other things, it does mean that it's going to work. And you're going to have a nice, comfortable house without any moisture issues, without any other things. So do go for that. The Passivhaus Institute basically introduced a thing called EnerPHit, which is basically allows you to then certify that project at the various stages. So you can make sure that you've got the long-term plan, the building plan for the project to make sure you can get to a very good end result. And each of those stages builds into that. So as you go through and you get a certification and as you go. So really, again, just talking differences between the deep retrofit and the shallow retrofit. So a deep retrofit, well, let's look at the shallow one first. So really, you're reducing the carbon emissions. You're likely then to say, okay, we're going to put a heat pump in to get the carbon down. Yeah, that's great, really hitting the carbon targets. But you've probably got quite a large renewable demand that way, and a large peak demand because the buildings, you can't heat the building up at night, say, and it'll be warm all day. You need to heat it when you need to heat it. So you've probably got to heat it during peak times, so when the sun isn't shining, so you're not getting that renewable energy into the grid. And so the grid is starting to then have to look much more at storage requirements. It's also between winter and summer, so really big storage requirements, which is going to be real challenges for the country as a whole to try and have that amount of storage. You may have some changes, little changes in bills as well, because you're kind of moving maybe off from oil or gas to electricity. Electricity is much more expensive than those two per kilowatt. So overall, it may not change that much in terms of your fuel costs. So your tenant might not be actually that much better off. Well, they won't be necessarily better off financially, so it's not necessarily. And again, they're then tempted not to turn it on, so that it's less warm, and there's the health benefits and all the other bits we spoke about earlier. But if you do go for the deep retrofit, then basically the peak loads are shared, because you can heat kind of the house when you need to, or when it's sunny, or when the energy demand is on the grid is less, so there's less grid storage requirement. There's less difference between summer and winter because the demands are lower, so we need to have less renewable things. We don't, as a country, we can build enough wind turbines and things to cope with that. We can't if we do shallow retrofits. So overall, if you look at the bigger picture, it's really important, I think, to go for the deep retrofits, as well as the other health benefits in terms of the demand on the NHS and all sorts of other things which we'll look at. So just summarizing really here now. So the Passivhaus stuff is really good. Mainly a lot of quality assurance as well. So we've got the buildings certified, we've got products that are certified. So the only thing I'd really suggest in terms of certified units, you do need to get a certified unit for the ventilation system. That's really the only one. Other units, you don't have to use certified windows. You just need to have very accurate and good data that you can prove it. You use a Passivhaus certified designer. You now have Passivhaus certified tradespeople. So again, they can go on a 1 or 2 day course to learn some of the key requirements of a passive house and make sure that they can do a good job and understand why you're doing it. One final thing here, I'd just like to say that building to passive house principles is not the same as a passive house standard. Going through the certification is much more rigorous. It will pick up things and make sure that it is a passive house. Otherwise, it's kind of, what is a passive house principles? It could be anything. And that's me, done. So thank you very much. If you want to get in touch with me, there's my email address. So please drop me a line or give me a phone call. And there's also obviously the social housing retrofit details there as well. Thank you very much and hope your bid goes well.